This is a video going through the third problem in the more triangle problems practice. So in this problem, we have 2 points moving around a square, and we're finding a formula for the area of the triangle formed by APQ until it gets to point C. So let's fill in some information we know. So we know, for example, that the square has length 4, so all these side lengths are 4. We also know the rate is 2 units per second, so let's fill in time. Time here is going to be, remember, distance is rate times time. So to find time, it's distance over rate. So it'd be 2 seconds. All these times are going to be 2 seconds. So 2 seconds, 2 seconds, 2 seconds. Okay, great. All right, and so then if we think about how we're going to break this up into a piecewise function, we'll be talking about one area of a triangle when P and Q are moving between AB and AD. So that's going to be between 0 and 2 seconds. So let's start writing this. So the area in terms of time. So we're going to have one piece that's going to go from 0 to 2 seconds. And the other piece will go from after 2 seconds until I get to the end, which will be 4 seconds later. Great. Okay, so distance is rate times time. So I know that both points are moving at a rate of 2 units per second. So distance can be thought of as 2t and 2t. So when we talk about an area of this triangle, it's a right triangle. So it's going to be 1/2 the base 2t and the height 2t. So that's piece 1. Piece 2 is more complicated, however, because we're turning the corner here. I'm going to erase this. And now we're talking about this triangle in here. And we're not dealing with a right triangle here. So the best way, like the one we did in class, to get at this area of this triangle as P is going from D to C and Q is going from B to C, is to do the area of the entire square and subtract the area of the 3 right triangles that are not shaded. So let's do that. The area of the square, I'm going to do it down below here. The area of the square is just 4 times 4 or 16. And then let's add up the area formed by the other 3 triangles. So let's look at this first one here. So one thing we do know, it's 1/2. We know the base is 4. Again, we're talking about distance. Well, the height is changing. And I can't just put in t, because if t was 5, this distance surely isn't 5. In fact, it would be 1, which would be 5 minus 4. So to find the height, the time is going to be t minus 4, but that's just time. Then we have to multiply it by the rate of 2 to get distance. So that height will be 2 times t minus 4. And the one over here is going to be similar as well. So we've got minus 1/2. We've got the 4. And how can we express this? It also will be, time will be t minus 4. And the rate is 2. All right. And last but not least is this piece here. Okay, so in order to get at the time, and then I can multiply by the rate here, and because both these sides, nothing's fixed, both are changing in this triangle. So if I want to think of the total time, because remember, time's on a continuum. If I think of the total time to get to C, that's 8 seconds. So I can think minus, I forgot the 1/2. 1/2. And this, to get at this length here, it would be total time, 8 seconds, minus time that's passed, which would be 2t. So 8 seconds minus not 8 seconds, sorry, not 8 seconds. Why am I doing time? Sorry, take that back. It's not 8 seconds. Total distance is 8 units minus the distance I've already traveled, which is 2 units per second times time. So that's how I can capture that piece there. And the same will be here. Total distance traveled is 8 units minus the distance traveled thus far is minus 2t. So again, each of those will be the same, and it's going to be the total, kind of like the other triangle problems. When with the second piece, we do the total distance the point has traveled, and then subtract out how far it's already gone. So it's going to be 1/2 8 minus 2t times 8 minus 2t. No need to simplify, but that's what you want to think about for that.